Hey, fellow mathers. Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam-packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over $6,000 worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians. Welcome to the podcast where math is figureoutable. I'm Pam.
And I'm Kim.
And you've found a place where math is not about memorizing and mimicking, waiting to be told or shown what to do, but it's about making sense of problems, noticing patterns, and reasoning using mathematical relationships. We know we can mentor students to think and reason like mathematicians. Not only are algorithms really not helpful in teaching mathematics, but rotely repeating steps actually keeps us from being the mathematicians we can be.
Which would be horrible. We don't want to keep people from being
Never. We believe in empowering and cultivating learning and reasoning. Bam.
Okay, so we're going to dive right in.
Dive.
Because last week we started chatting about order of operations, which is a super popular topic in all of our groups. I don't know if everyone knows this, but we have a teacher Facebook group. We've got a group for Journey, which is our online implementation support. We have a leader Facebook group. All the Facebook, I spend some time in there. And in each of those groups, there are great questions where people really do want to help their students have more understanding about a ton of topics. So order of operations has come up several times. Actually, Carlo in our Journey group said, 6th graders will be starting with order of operations. How would you teach this topic using thinking and reasoning as opposed to a mnemonic and a list of steps? I love that. That's such a great question.
Nice.
And also, I found that Jennifer Battis-Smith had said, any ideas for 7th grade order of operations number strings, which we call problem strings, but we'll let that go. Because these people are really thinking about making meaning. And so let's dive in and answer.
Absolutely. Yes. Carlo and Jennifer, thank you. And a ton of others. Just for you today, we are going to do at least a problem string toward order of operations. So in the last episode, we talked all about it, issues, defining it. Today, let's get at what to do to develop order of operations. All right, to do this today, we're going to give a hat tip to our friend Nat Banting, who might be one of the funniest secondary math teachers I've ever met.
Oh, that's good.
Yeah, you'd like him. There's definitely some snark
I do like
there. It. Yeah, we both appreciate a good sense of snark. Anyway, so Nat Banting has a structure, a routine structure that he calls something like "Oops, I meant." I hope I have that right. Oops. Instead, I meant this. And I'm going to respectfully suggest that that is a twist on facilitating a problem string structure, so that we can do a problem string in a Nat Banting "Oops, I meant" style. So let me give you an example, and then Nat, you can shoot back at me what you thought about my idea of how "Oops, I meant" could kind of belong as a way, not the only way for sure, but it's sort of a twist on facilitating a problem string. All right, Kimberly, you ready?
Yep. Oh, you're gonna give me a problem.
I'm gonna give you problems. Yep. Okay, you walk in the store with $20. This is important. You have $20.
Is it my 20 or you give me 20?
You have 20 in your hands. I don't know where you got it from.
Okay. I'll use mine.
Maybe I handed it to you. I don't know. But it's in your hand. You get $20. Now, I know that that's a little bit, maybe some of our students don't have a lot of experience with money, to which you and I loudly say, then give them experience with money. Yep. So here's an example of that, where we can acknowledge they're swiping with cards all over the place. We're going to actually do this problem, not expecting they come with experience, but that part of it could be they're gaining experience. Okay. You have $20. All right. you walk in the store with that $20 and you buy 4 pens, not pencils, Kim, pens.
Okay.
You buy 4 pens and they're 50 cents each
Okay.
and a $3 notebook.
Okay.
How much do you have left?
4.50. Do you care how I'm thinking about it? 4.50,
Well, tell us about it. Yeah.
$2. And I bought a notebook. That's $3. So I have spent $5. You want to know what I have left? Or what I
Yeah.
spent?
What
Oh,
you have?
so if I spent 5 and I had a 20, I got $15 left.
Okay. So as you were talking,
Yeah.
I might write on the board. You said 4 times 50 cents. So I wrote 4 parentheses 0.5. And then you said you're going to add to that $3.
Yeah.
And then you said, I've got to subtract all that from 20. And so I wrote 4 parentheses 0.5, close parentheses, plus 3. And then I put parentheses around all of that. And I wrote in front of it 20 subtract.
Okay.
Would you agree that that is what you just did?
Yes.
Okay. And I might even then right next to it, 20 subtract, and you had said 4 times 50 cents was $2. So 20 subtract parentheses, 2 plus 3. And then I might write that's equivalent to 20 minus 5, which is equivalent to 15. So I kind of have this run-on sentence thing here where I have kind of this longer expression, and then I simplified the expression the way you said to, and then I simplified it again, and I just kind of kept going until you said you had $15 left.
Yeah.
Next question.
I'm.
Oh, go ahead.
Oh, I don't want to interrupt in the middle of your problem story.
Well, I mean, we
Well,
often
because
interrupt each other.
I did not, as you were reading back to me what I did, I did not actually put brackets,
Mm-mm.
but to be completely accurate,
Mm-hmm.
I could have gotten 15 without them. But to be completely accurate about what we're communicating, I did multiply the 4.50 cents and the $3 and then take it from the 20. So
Yeah,
that's,
you did
yeah.
stuff first. And
Yeah.
so what you're saying is if you look at 20 subtract grouping 4 times 0.5 plus
Yep.
3, it looks like you did something with the 20 first.
Yeah, I mean, I would get 15, but if we're talking about the opportunity to communicate clearly about what I actually did,
Mm-hmm.
then perhaps I should have used a bracket.
Well, and so to be clear, if I'm doing this in class, I don't actually care what the student wrote down.
Yeah.
I'm going to write down on the
Yeah.
board a way that we have agreed as a society communicates what
Yep.
you did.
Yeah.
Cool. Next problem.
Okay.
You got $20. You walk into a store.
Mm-hmm.
You're going to buy a 50-cent pen
Okay.
and a $3 notebook.
Okay.
You got them in your hand.
Yep.
And then you realize, 4 kids, Pam. Okay, so you're being me now because I have 4 kids. You need 4 of those.
Mm.
How much money do you have after
So
you do that?
it'd be $3.50 for one of your kids, but you have 4 of them. So double it is 7. Double it again is 14. So you're spending $14. So that means you have 6 left.
Okay, and so as you were saying that, I wrote down, you said $3.50 per kid. And so I wrote down 0.5 plus 3 because it felt like you did that first. So even though you didn't say it.
50 cents plus 3?
Uh-huh.
Yep, that's what I did
Yep.
first. Mm-hmm.
Yep. So 50 cents plus 3. Felt like you did that first. So I wrote that down. And then I put parentheses around that.
Yep.
And I wrote times 4, even though you found times 4 by doubling and doubling again.
Sure.
Okay. So now I have 0.5 plus 3, parentheses around that with a 4 out front.
Yep.
And then you had to take that from the 20. So then to the left of that, I wrote 20 minus.
Mm-hmm.
So on my paper right now, or on the board, whatever, I have 20 minus 4 times the quantity 0.5 plus 3. And then I could simplify that. I'm not going to do it maybe for the podcast, but with students, I would simplify that. And then, well, maybe I will. So I would have 20 subtract 4 times 350. And you said 4 times 350 was double 7, which is 14. And so 20 minus 14 is 6.
Mm-hmm.
So I now have kind of this running equation where we sort of did what you did. And we're now like, did we communicate? Yes. And that was the outcome that you got. Next problem. How about you, now I have to think for just a second. I can't read my own writing. You did what you just talked about. So we had you picked up the notebook and the pen. You realized you needed 4 of them. But as you walked up to the person to pay, they said, "Did you know there's a coupon?"
Mm.
And Kim, you're kind of frugal.
I am.
So you said, I'll take that coupon. Well, the
Mhm.
coupon was 75 cents off.
Tell me again. I bought 4 pens.
You
Did
bought
I?
a pen and a notebook and then
Ugh,
realized you needed
sorry.
4 of them.
Yeah. Okay. Pen and notebook. Sorry.
And
Yep.
then you realize you need 4 of them and
Yep.
you have $20 to pay that.
Uh-huh.
But there's a coupon for 75 cents.
Yep.
Okay, so how much money are you walking out with?
So I bought the pen and the notebook. That was $3.50. I needed 4 of those sets. So that's $14. But I used a coupon for 75 cents. So that said I spent $13.25. Actually, I probably, yeah. So that's $13.25 I owe. And I'm taking that from the $20, which means I have $3.75 left.
Say that again. Did you
Sorry,
say
3.25. No,
you
no.
I
I
think
have the pen and the notebook. That's
yeah.
3.50.
Yeah.
I got to buy that 4 times, so that's $14.
Yep.
I took the coupon off, so that's 75 cents off. You said the coupon was
Mhm.
75 cents.
Mhm.
So I'm only spending $3.25.
Uh 13.25.
$13.25. Sorry, I even wrote that. So I'm spending $13.25 and I have $20.
There we go.
So I have $6.75 left.
All right. There. Yep. Okay, cool.
Sorry, did I say
No, you're
that?
good. You're good. So on the board, I
Yep.
actually have exactly what you had for the problem before.
Yep.
The 20 minus 4 times the quantity, 0.5 plus 3.
Yep.
But then I put parentheses around all of that. And I said, oh, wait, not all. Not all of that. My bad. Sorry. The 4 times the quantity, 0.5 plus 3,
Mm-hmm.
that was your 14. And you're
Mm-hmm.
like, yeah, but I don't have to pay 14. I only have to pay 75 cents less than that.
Mm-hmm.
So that 4 times the quantity, 0.5 plus 3, I then subtracted 0.75.
Mm-hmm.
And I put parentheses around all of that and took that from 20. So I've got 20, subtract all of that stuff. And then somebody in the class is going to say, isn't it kind of like you did what you did before, but you just can add that 75 cents
Mm-hmm.
back? And now we can talk about why 20 subtract that subtract 0.75, subtract, ends
Mm-hmm.
up being adding that 75 cents because you had $6 before. And now with that 75-cent coupon, it's just $6.75.
Yeah.
And so it's a nice kind of way of sort of talking about how are we communicating. Okay, last problem.
Okay. That's a lot of pens and notebooks I'm buying.
You're doing a great job. It is a lot of pens and notebooks. And
Beginning of school year.
is it killing you a little bit that it wasn't pencils and
No, it's
notebooks?
fine. Pencils come in a pack and they're not 50 cents. So pens are more realistic because they're cheap and horrible.
And now you know how Kim feels about pens. Okay, Kim, you're going to do a similar thing that
Yep.
you have the 50-cent pen and the $3 notebook. So
Yeah.
I've just written down 50 cents plus $3.
Yep.
And you need 4 of them. So now I've got the 4 outside the parentheses of that.
Okay.
You got the coupon for 75 cents off. Subtract the 75 cents from that.
Yep.
Hey, but wait, you owe me $2.
Okay. So I had $13.25, but I owed you $2. And now I
Hmm.
only have so I had $6.75. I was spending $13.25, which means I had $6.75.
Mm-hmm.
But I owe you $2, and now I only have $4.75.
And now we could have a conversation about where do you want to put that subtract 2? And that subtract 2 could go in a couple of different places at least. We could subtract it right off the bat. You could have said, well, I had 20 and I just decided, here's your 2. Now I had 18, right? We could have done that right off the bat. We could have subtracted the 20 at the very end of the whole transaction. We could have subtracted the 20 inside of the 20 minus. If we were careful about how we did that, we would have to reason about what to do with that $2. And we could do it in several different ways and make sense of why sometimes it's minus 2 and sometimes it's plus 2.
Yeah.
And I'm not even going to say too much more about that. And that, oh, here I gave a hat tip to Nat, and then I so didn't even do it. Nat, I'm so embarrassed. Okay, Kim. Y'all, do you ever do this? You get up in front of your students and you have a plan, and then it kind of. So what I just did was I went kind of into problem string mode, not like Nat's oops, I meant. So let me try to just repeat quickly what I would have done in Nat Banting's oops, I meant facilitation. I could have said, hey, Kim, you walked in the store and you bought 4 pens at 50 cents each and a $3 notebook. You had $20. How much did you spend? Once she did that, then I could have said, oops, oops, I
Mhm.
meant you walked in the store, and then I would give the second problem. And
Yeah.
then I could have gone, oops, 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 I meant there was a coupon. And then I could have said, oh, oops, I meant you owed me $2. How much money did you have at the end? So that would have been a better hat tip to Nat Banting's "Oops, I meant" facilitation. Sorry, Nat. And I think I think it would totally work well to do it either way.
Yeah.
But I think it's kind of fun to do the "Oops, I meant," and students
Mhm.
tend to kind of smile a little bit, and they kind of know what's coming. And it's a fun way to kind of play a little bit with this problem string structure.
Yeah.
Let me back out a little bit and say, what did we just do? I gave you kind of a scenario of what was happening. And as you actually did the thing, so this is important, teachers, you actually have the kids do the thing. Then you represent what they did and say, hey, this is the way we would communicate those words I just said and the thing you did in your head. This is how I could communicate what you just did. We use these symbols to communicate what you just knew to do. This is how we use those symbols. And as the string goes along, oops, I meant something different. You do it, and then we communicate how we would represent that, how we as a society have decided that if we wrote it this way, we would all know we mean it to be that way. That is a problem string to help. Quickly, I'll just give you kind of after you've done that in context. Now, I would do that in several different contexts, and I'm making up a few of those. I'll be putting them out on social media. Y'all follow me on social media. We'll put them out. But as you do that in context, you could also then do things not in context. You could say, all right, we've done a few of these in the store and wherever. Here's one where I just say the number 3, I want you to square it. Then I want you to add 6. Oops, oops, I meant add 6 to 3 and then square that. Square the total. Oops, I meant. And then you just keep switching it up. And as they do the thing, you represent the way it would look. So we make sure we're communicating. In other words, if this is the code, so now you want to be able to look at what's on the board, what you've written. If this is the code, what did the person mean? How are what are they trying to communicate? That's the purpose of order of operations. And then kids can get good at, oh, I can recognize when my brain does this, it looks like that. So now when I see that, if that's the code, what did the person actually mean? Please, teachers, don't expect that the first time you do that, oh, bam, kids have got order of operations. We are done. Give them the test. No, because there's a lot for them to fuss with. There's a lot for them to build in their brains about order of operations. There's the social part about what the notation means. There's the logical mathematical part about what they were actually doing. And then there is the decoding part. Remember, the first is they did it, you represented it. Now they're like, okay, that's what the code could look like. Now you're going to come backwards and you're going to go, if this is what the code looks like, what was happening? And in fact, I didn't do it in this particular problem string because I don't usually do this in the first go around. The second or third problem string could have as a last problem. In other words, I keep saying, do this, da, 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 I represent, oops, I meant, now represent it, oops, I meant, now represent it. The very last problem could be, here's the code. What was happening in the store?
Hmm.
Now I just show you the code. You tell me what was going on in the store and how much money did you walk out with. That transition. So don't expect that at the end of one short experience, kids are going to be coming out with it exactly right. And you might say, I don't know, Pam, when I just gave them PEMDAS and I just had to mimic me, they were all getting right answers by the end of the day. And I will believe you. And then I will tell you it didn't stick and it didn't work for most kids because they didn't actually understand what was going on. And all they did was mimic and wrote memorize. There were a few kids that probably were able to reason through it and kind of figure stuff out and they were able to move on. And maybe that was you, math teachers. But all kids can math if we help them actually reason, build the reasoning as they're going, understand what's happening, and make sense of order operations as a communication tool. All
Yeah.
right, Kim,
Yes.
let's talk about what are some things that we can do with students.
Yeah. So even with very, very young students, when they make a statement that's mathematical, you can say, as you're writing, mathematicians communicate that like this. So even in a very young age, we could see students or we could have students say something and we add grouping symbols to help them see something for the first time. We're not expecting them to use grouping symbols. We're not expecting them to go back to their desk or table and record with grouping symbols. But as we hear them say, first this, then this, we can
First,
add those.
yeah, first I added these 2 things
Yep.
together, and then I
Uh-huh.
added that thing last. The teacher can put
Absolutely.
parentheses around those first 2
Yep.
numbers, and again, like you said, we're not expecting students to do it, but
Right.
they are seeing, "Oh, I can help communicate by
Right.
using those grouping symbols." Nice.
Right, because those symbols will be new to them at some point, and if we can let them know early on, "Hey, this is how mathematicians communicate what you just said." Um,
Bam.
we do that with kindergartners. So, the other thing that we can do is have them, like you said, with some when they see stuff, we are talking about what is this trying to communicate, and we can dig into the conversation about what do you think that means, and what does that look like, so that they start to understand that there is a language that we're using in mathematics.
Yeah, very nice, and let me give you listeners one example, one tiny example of something that could come out of the strings that we did today. You might have noticed that I said I would write down the expression that represented what Kim did. Then I would write equals, and I would write down sort of the next thing she did. I would kind of simplify things. I would combine things that she had combined. Equals, and then the next one, and then the answer, which means I now have a string of equivalent expressions. And I am purposely using the equal sign to mean that this thing on the left is equivalent to the next thing. I am not using the equal sign incorrectly as a do it symbol or
Yeah,
as a and then I did. I'm using
right,
it as a these two expressions are equivalent. That's what the equal sign means. So I'm using that equal sign correctly, which is sending the message to students. This is what the equal sign means. This is
right.
how it's communicating. This is what it's communicating, is that these two are equivalent. So we want to be really careful. We should do a whole episode, Kim, on just the meaning of the equal sign
Mhm.
and how it's not a do it symbol.
Well, and
That is fantastic.
can we add in that sometimes we shy away from some of this notation until it's time to open up and say, we're going to talk about order of operations. And so,
Mm,
all of a sudden, kids are seeing all this stuff for the first time and they're like, wait, what do I do first? And why am I supposed to do that first? So, we're talking about layering on symbols along the way so that these are not new symbols that they've never seen before.
it doesn't have to be introduced in the chapter. You're going to test it.
Right, right, right,
Let's
right,
introduce
right.
it far earlier
Yep,
in order to communicate.
yep.
And for Pete's sake, don't make it unnecessarily
Oh gosh,
hard.
yeah. There's
There's
no need. Yeah.
yeah, go ahead.
There's no need to create a string of numbers. We've seen it often that if kids can do these really hard ones, then that must mean that they understand order of operations. Um, and we're trying to see if they can follow along under the guise of do they get it? And we're gonna say, who's that really helping? And-
Yeah, like if you have a couple kids in your room that it's like a puzzle to them and they
yeah,
really enjoy these 20 operation long with all the crazy symbols and
yep,
that's fun for them to figure out the code. By all means, let them but that we're just going to suggest though that's too it's not helpful.
right.
Don't make it unnecessarily
Feels
hard,
tricky, quizzy,
please.
like
Yeah, yeah. If you want it to be puzzly, put it in a puzzly kind of thing. If you want it to, if we're trying to help kids really communicate well, do enough to communicate well. Make it be about communication. All right, y'all. We're gonna do more with PEMDAS in the future, so keep tuning in. And thank you for being here and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Thank you for helping spread the word that math is figureoutable. Thank you for listening and making math more figureoutable.
to learn even more, make sure you register for our free challenge at mathistfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figureoutable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.